So now let's discuss example number 3. Hi. Okay, now let's discuss example number 3. This one. A researcher claims that the average cost of men's athletic shoes is less than RM80. He selects a random sample of 36 pairs of shoes from a catalog. So this is our first, actually this is our second information, a sample of 30 pairs of shoes. So you have a sample of uh, 36 pairs of shoes, and this is actually what we want to uh, test. It's less than RM80. So this is the mean actually that we want to test. And again, as per discussed yesterday in our class, I've mentioned that what is mentioned in the question is actually our uh, alternative hypothesis, because this is step 1, okay, hypothesis. So we want to test if the men's athletic shoes is less than RM80. Less than RM80 here is our alternative hypothesis that we want to test. So alternative hypothesis H1 is equal to mean is less than RM80 ringgit. And again, for the null hypothesis, it is always equal to mean is equal to RM80 ringgit. Just to be safe, just use mean. Okay. And he selects at random a sample of 36 pairs of shoes from a catalog and finds the following cost rounded to the nearest RM. So these are the cost of the shoes. For the first pair of shoes is RM60, second pair of shoes is RM50, and the last pair, the 36th pair of shoes is RM70. Okay, is there enough evidence to support the researcher's claim at 0.1%? At, sorry, bukan, no, at alpha significance level of 0.1. And assume that the standard deviation of the population. Now, you need to be very careful here because the symbol used here is the sigma instead of S. So if sigma is given, then we know that the standard deviation of the population is known. Okay, so when it is known, therefore we need to use the formula with Z, critical value. So we need to use this formula. Yeah, the Z, not with the T. Okay, so that is step 1. And for step 2, step 2 is the significance level. Just write down the significance level from the question. Alpha is equal to 0.10. Okay. For this one, you don't need to um, you don't need to divide the alpha by 2. In the previous example, example number 2, we divide the alpha here by 2. Why? Because we are testing at both sides of the distribution. Because the alternative hypothesis here, yeah, this one. Okay, we are testing alternative hypothesis that is not equal to. When the alternative hypothesis is not equal to, only then you need to use alpha over 2. Okay, this one. Okay, this one. But when you use, when in the alternative hypothesis, you have less than or greater than, you don't need to divide the alpha by 2. Just use alpha 0.10. Okay. And next step is this test statistics, right? Test statistics. So step 3 is the test statistics. All right. Before you can proceed with the calculation of Z calculated here, uh, you need to find the X bar first, the mean of the sample, because it is not given. Instead, the question gives you the raw information, the raw data here. Okay, and you need to calculate the X bar based on all information given here. So therefore, X bar, sorry. So X bar is equal to summation of X over N. So what is summation of X? That is actually equal to the summation of all information up here. So 60 plus 50 plus 120 plus the last one, 70. Okay. And how many samples are that altogether? We have 36 pairs of shoes. Okay. Solving this equation, you will get the X bar, the mean of the sample, that is equal to 75. Okay, 75. Okay, now you have the X bar. Then you can calculate the Z calculated, because the Z calculated is equal to X bar minus mu over standard deviation of the population over square root of N. Don't worry, this formula will be given in the test or in the final assessment. Uh, you just need to make sure that you know which one to use. Okay, give me a second. There's one student requesting to join this class. All right. Okay, so now we can proceed. Okay, I will proceed. So our Z calculated is equal to X bar. Is this value, okay, X bar, 75 minus 80. This is what we want to test. Minus 80, the mean that we want to test. The standard deviation of the population is given 18.89 over square root of 36. Okay, so solving this equation, you should get the Z calculated value of negative 1.5881. Negative 1.5881. Okay, uh, you must remember that usually when we want to test, the mean is less than. Okay, when the alternative hypothesis consists of this symbol, less than symbol, you should get a negative value at the Z calculated. You should get a negative Z calculated value. But if the alternative hypothesis, for example, the alternative hypothesis is mean is greater than RMAT, so if this is the case, then you should get a positive value for the Z calculated. But this time we have less than symbol used in the alternative hypothesis, so that is why the Z calculated value is negative. Okay, because the we are testing the hypothesis at the left side of the distribution of the Z distribution. So this is left tail test. Okay, this is left tail test. All right. So now you have calculated the Z calculated. Step 4 is to find the critical value or ZCV. Again, if you use the Z calculated, then you have to compare it with the Z critical value. I will write down here. Write it down. Z calculated compare with Z critical value. T calculated compare with the T critical value, and P value. Later we will discuss how to read the P value. You need to compare this one with alpha. Okay, remember this one. Never ever compare the Z calculated with alpha or T calculated with the Z critical value. No, it must be uh, like this. Okay, Z calculated with Z critical value, T calculated with T critical value, P value with alpha for comparison purpose. Okay, now, since we get negative value here, the Z critical value should be also negative. Okay, just add the negative symbol there. Okay, so now our Z critical value is Z alpha. That is equal to Z alpha. Again, you don't have to divide this alpha by 2 because we are now testing at only one side of the distribution, left tail. Okay, and Z, this is negative Z 0.01. Okay, negative Z 0.01. So from here, go to the statistical table, find 0.01 from table 4 here. Okay, from table 4. So Z 0.01, this is the value 2.3263. 2.3263. Go back to the module. So the value is 2.3263, and don't forget to insert the negative value. Okay. Next is this is, let's say, wait, yeah, I draw it once again. This is the Z distribution, and your Z critical value is here. Z critical value, negative Z critical value is equal to negative 2.3263. Remember, this is the rejection region. Rejection region means that if the Z calculated falls under this region, we will reject H null. But if the Z calculated falls within this region, we fail to reject H null, fail to reject H null. Don't bother about this region because we are only testing at on one side of the distribution only. Right now, our Z calculated is negative 1.5881. So negative 1.5881 is actually here. This is our Z calculated, negative 1.5881. It is greater than the Z critical value. Okay, therefore, uh, in step 5 for the decision rule, you can just simply um, write down what is mentioned here, up here. Okay, so now we have a known standard deviation. So we will not use this one. Okay, and then we are testing the hypothesis at the left tail test. Therefore, the decision rule is reject H null if Z calculated is less than or equal to negative Z alpha. And you should remember, if only two tail test, we will compare with Z alpha over 2. But if one tail, we will compare with Z alpha only. Okay, Z alpha only. Now, the decision rule is reject H null if Z calculated is less than, reject H null if Z calculated is less than or equal to negative Z alpha. Since Z calculated is negative 1.5881 and the Z critical value is negative 2.3263. Okay, this one Z calculated is greater than the Z critical value. We can only reject H now if Z calculated is less than or equal to Z critical value or Z alpha. Same. Okay. This is also equal to Z alpha lah. So for the decision here, I will write down here step 6, the decision. Can we reject the H now? Sorry, the decision. Can we reject the H now? No, we cannot reject the H now. Fail to reject H now because why? Because the symbol here is greater, but to reject the H now, we need to have a set calculated that is lower or less than the negative Z alpha. So the decision is fail to reject H null. Fail to reject H null. And last step is to draw a conclusion. So what is the conclusion, anyone? Conclusion, anyone? The conclusion is now to draw the conclusion, refer to what you have concluded up here first. If reject H null, you should conclude sufficient, there is sufficient evidence, or it is sufficient to conclude that. But now in our case, okay, In our case, we failed to reject additional, so there is insufficient evidence to conclude that right what you have mentioned or what you have stated in the alternative hypothesis. What is the alternative hypothesis? The mean price of shoes is less than RM 80 ringgit. Or you can also get the statement from the question. This one. Uh, if in this question, it is actually, oops, example number 3. The average cost of men's athletic shoes is less than RM 80 ringgit. So you can use that one. The average cost of men athletic shoes is less than 80 ringgit. The average cost of men's athletic shoes is less than RM 80 ringgit. All right. Any question before we proceed uh, with the next example? Any question? Example number 3. No
No,
question.
doctor. No, doctor.
All right. Thank you. All right. So if there's no question, I will proceed with example number 4. The Minitab output for the data in example 3 is as given below. Use p-value. Now, you need to use the p-value. Remember, if the question asks you to use p-value, but you use the test statistics as per discussed earlier, you won't get any mark for the calculation or for the method. You will only get mark for the final answer. So please be careful, read the question carefully, and if the question asks you to use p-value, then please use the p-value to test the hypothesis. Okay. All right. So it is actually the same thing. We have calculated the Z calculated. We already get the Z calculated, which is equal to negative 1.5881 earlier. But in the output, it is only reported at 2 decimal places. That is why the Z calculated in the output here is equal to negative 1.59. And this is the standard error mean. This is the assumed standard deviation. We have discussed this before. If the assumed standard deviation is given, it means that the standard deviation here is actually the standard deviation of the population. And down here is the standard deviation of the sample. This is the standard deviation of the sample. If sigma is given, use sigma. Do not use S, the standard deviation of the sample. If sigma is not given, only then you can use the standard deviation of the sample that is equal to 19.16, 19.16. Okay, and this is the mean value 75, the mean, the sample mean 75. We have calculated the value here. right? 75, the sample mean. And we have 36 pairs of shoes, and we want to test if the shoes is less than RM 80 ringgit or not. All right. To use the p-value, you can just repeat the same steps. For example, you can write down the hypothesis first. Step one, hypothesis. So the hypothesis is H null mean is equal to RM 80 ringgit, and alternative hypothesis mean is less than RM 80 ringgit. You know, right? Less than. Follow what is used in the output. And for step two, the significance level. And from the output, we know that the significance level is alpha is equal to 0.1. Why? Because it used 90% here. So 90% confidence level is equal to 10% significance level. I've explained this in our previous class. 90% confidence level in chapter 2, right? In chapter 2, the it is always about finding the 90% confidence interval. Okay, so the alpha is 1 minus 0.9, so you will get 0.1. So this is the alpha. Alpha is equal to the significance level. That is how to find it. And then step 3. Okay, so the step 3 is where it differs from the previous example. In here, step 3, we use test statistics up here in the previous example, but in our current example, step 3, instead of using test statistics, we use the p-value. Where is the p-value? This is the p-value, 0.056. 0.056. So you can just simply write the p-value 0.056. And again, you should compare the p-value only with alpha, right? So this is the alpha. You need to compare these two values. And that is why for step 4, the decision rule reject H null if p-value less than alpha. I just want to check if it is less than or equal to. All right. Here, reject H null if p-value less than or equal to alpha. Or equal to. So, less than or equal to alpha. And step 5 is the step 5 is the decision. Okay. If you use the test statistics, you should have 7 steps altogether. 7 steps, right? But if you use the p-value, there are only 6 steps. Only 6 steps. So step 5, sorry, before that, since p-value is equal to 0.056 and alpha is equal to 0.10. 0.056 and alpha is equal to 0.10. This one, it is less than, right? Less than. Let me check. Why this time it is reject? Oh, sorry. I think this one is sorry, yeah. Let's check the previous example. Alpha here is z 0.01. I think, sorry, 0.1. Okay, my mistake. I'm so sorry. Uh, in the previous example, it is not actually 0.01. Okay, please be careful because previously we used this value 2.3263, but our alpha is not 0.01. Our alpha is actually 0.1, this value 1.2816, 1.2816. So this is actually our alpha, right? So we need to change a bit here in our previous example. In our previous example, our alpha is not 0.01. This is 0.1. And for alpha 0.1, the value is 1.2816, right? Check again. 1.2816. Yes, 1.2816. It is not 2 point. So this value is negative 1.2816. So here, let's draw this again. Okay. So this is your Z critical value, negative Z critical value of which is equal to negative 1.2816, and your Z calculated is negative 1.5881. So this is your Z calculated. Z calculated negative 1.5881. It falls under the rejection region. Okay. And that is why here we need to change, since Z calculated is less than negative Z critical value, which is equal to 1.2816. Therefore, we reject H null. Decision is to reject H null. And for step 7, instead of insufficient, now we have sufficient evidence. Okay, we have sufficient evidence. Sufficient. Okay, now it makes sense. Since p-value, for example number 4, since p-value 0.056 is less than alpha, so the decision is the same. I will speed it. So step 5 is decision. So you should get the same decision, that is to reject the H null. So reject H null. Okay. Reject H null and reject H null. And for step 6 is the same step, is same conclusion, you can just write it this conclusion again. You must remember most of the cases, regardless of the approach you use, whether you use the p-value, whether you use the test statistics or the confidence interval, in most of the cases, you will get the same answer. If the decision is to reject H null, in one method, usually in other method or approach, you will also reject H null. Dia tak ada satu reject, satu fail to reject. Ada tapi sangat-sangat jarang berlaku. Sangat-sangat jarang berlaku. Alright. Okay. Any question? All good? Please respond, guys.
All good, sir.
Okay, thank you. If no problem, no question, I will proceed uh, with the next example, yeah? With the next example. Example 5. But I want to give a few seconds for you to ask question if you have any. Okay, no question. Now, let's proceed with example 5. A psychologist claims that the mean age at which children start walking is equal to 12.5 months. So this is the average children start walking. Therefore, write down the information. This is the mu because uh, it is not based on the sample. Okay, it is based on the population. So mean or mu mean of the population is equal to 12.5 months. This is what the psychologists claim. Months. Carol wanted to check if this claim is true. She took a random sample of 18 children. She took a random sample of 18 children and found that the mean age at which the children start walking was 12.9 months. So from the average, from the sample of 18 children, Carol found that the mean of the sample, okay, start walking is 12.9 months with a standard deviation of 0.8 months. This is a different case. In our previous examples, the standard deviation used or given is the standard deviation of the population. But this time, we know that the standard deviation of 0.8 month is referring to the standard deviation of the sample. Okay, kalau awak baca, dia sambung ayat dia. These children started walking was 12.9 months with a standard deviation of 0.8 months. So, this standard deviation is referring to the standard deviation of the sample and not the standard deviation of the population. So this is S. It is not T. Standard deviation of the sample is S 0.8. So if the standard deviation of the sample is given, for this case, you need to use the formula with the t, not the formula with the z. Or in other words, you need to use or you need to find the t calculated. Okay, find the t calculated. If sigma is given, find z calculated. If s is given, standard deviation of the sample, find t calculated. And if z compare with z alpha, I will just write z critical value. It refers to z alpha or z alpha over 2. Z critical value if t calculated compare with t critical value. Okay, so we have z alpha over 2 or z alpha. Or for t, we will have t alpha over 2 degree of freedom or t alpha degree of freedom. All right, so now you need to find the t calculated. But again, uh, for this example also, you need to write the step-by-step approach lah, step-by-step approach. So step 1 is the hypothesis. Again, so the hypothesis, null hypothesis is first, we write the alternative hypothesis first because it is based um, from the question. So what we want to test? We want to test that the mean age at which all children start working is older. Okay, this is the keyword, is older. So mean is greater than 12.5 months. So this time we are conducting a one tail test or a right tail test because this symbol is used, greater than. And for the null hypothesis, it is again just use the equal to symbol. It is equal to 12.5 months. And step 2 is the significance level. What is our significance level? 1%. In our previous example, this one is 10% significance level, but this time 1%. So 1% alpha is 0.01, 1%. Step 3 is the test statistics. So instead of calculating the Z calculated, we need to calculate the T calculated. And from the formula, the T calculated is given by X bar minus mu. That's just the same, but uh, down here, we use standard deviation of the sample. Standard deviation of the sample over square root of n. So our X bar is 12.9 minus mean that we want to test is 12.5 over standard deviation of the sample is 0.8 over square root of 18. Square root of 18. And solving this equation, you should get the t calculated that is equal to 2.121. 2.121. Now, let's look at the value here. We get positive value. Why? Because we are testing at the right tail test. Okay, we are testing right tail. If you are testing left tail, you should get, oh sorry, previous example. If you are testing left tail, you should get a negative value. Right tail, you should get positive value. Okay, right tail, you should get positive value. All right, test statistics done. And step 4 is to find the critical value, which is equal to the T critical value. It is not Z critical value because we calculated the T cal, not the Z cal. So you have to find the T critical value. So the T critical value is equal to T alpha, and the degree of freedom is equal to n minus 1. N minus 1. Why alpha? Why not alpha over 2? Why only alpha? Because only one side of the distribution that we are testing, one tail test or right tail. If two tail, only we divide alpha by 2. One tail, alpha only. So now our alpha is 0.01, and our degree of freedom is n minus 1. That is equal to 18 minus 1. 18 minus 1, which is equal to 17. And let's find this T critical value. Go to the statistical table and find the T table. Table number 7. This is the where you can find the T critical value. So our alpha is 0.01, and the degree of freedom is equal to 17. Oops, 17, and the value is, oops, where is it? The value is equal to 2.567. 2.567. Go back here. Therefore, um, the critical value is equal to 2.567. And step 5 is the decision rule. Decision rule. You can check the table again, the table up, I think in page 3. Okay, so based on the table in page 3, the decision rule, okay, I will show lah. I will show, wait, yeah, page 3. Okay, so this is the table again. This time we use uh the standard deviation. The case is the standard deviation of the sample is given. So it is the type of distribution is this one. So do not use the upper one. And now we are conducting a right tail test. Why right tail test? Because the symbol used in the alternative hypothesis is greater than. That is why it is a right tail test. So the decision rule is rejectional if t calculated is greater than, okay, greater than t alpha, so t critical value lah, t critical value. So uh, go down here. We are now discussing example number 5. You need to compare this value with this value. So reject H null if t calculated is greater than t critical value. Calculated is greater than t critical value. By the way, this is the t critical value. Yeah? Since t calculated is equal to 2.121 and the t critical value is equal to 2.567. Now, 2.121 is less than or greater than 2.567. In case you confused, just draw the distribution. This is right tail test, right tail test, and your t critical value is equal to 2.567 and 2.121 is here. This is the t calculated 2.121. It is less than. Now, we can only reject H now if it is greater than. But what we get is we have a less than value. So for the decision, step 6, decision, can we reject the H null? No, we cannot reject the H null because the T calculated is it doesn't fall under this region. This is rejection region. So for the decision, fail to fail to reject H null. And what can we conclude if we fail to reject H null?
There is
It is
insufficient evidence
okay, there is insufficient evidence
at 1% significance level.
at 1% significance level that
The mean
that
age
um, the mean is
at which all children start walking
all children start walking
is older than
12 point
12.5 months.
5.
Yes.
All right, 12.5 months. Thank you. All right, so remember, you can get these, which all children start working is older than 12.5 months. This is actually our alternative hypothesis, okay? Because we are testing the alternative hypothesis. And usually the alternative hypothesis is mentioned in the question. And if we fail to reject H null, we have insufficient evidence. Any question? No question?
No.
Okay. Okay, we have two examples left. Okay, so I will just proceed, yeah, with the next example, example number 6. An educator claims that the average salary of substitute teachers in school is more than, yeah, again, it is more than RM 55 per day. A random sample of 8 schools is selected and the daily salaries in Ringgit Malaysia are shown. Is there an, is there enough evidence to support the educator's claim at alpha 0.1? So now for this one, we have a sample of 8 schools and X bar is not given. You have to calculate the X bar by yourself. So X bar is um, summation of X over N, and it is equal to 60 plus 56 plus 55 over 8, and the X bar is equal to 58.875. 58.875, and the mean that we want to test is given, that is equal to 55. Okay, RM 55. This is also RM 58. And what else? Okay, the alpha is 0.1. So again, just use the test statistics procedure. Step 1 is to write the hypothesis, which is H null and H1. Null hypothesis and alternative hypothesis. Again, what is mentioned in the question is the alternative hypothesis. So what we want to test is whether the salary of the mean salary of the substitute teachers in school is more than RM 55 ringgit. And for the alternative hypothesis, it is always equal to, okay, 55 ringgit. And step 2 is the significance level. Significant level. Okay, okay. And the significant level alpha is equal to 0.10. But if you notice in this question, example 6, the the standard deviation or the variance of the population is not given, as well as the standard deviation or variance of the sample is given. Both of it is not given. So what you have to do? What you have to do is actually from all these data, this is our sample, right? This is our sample. You have to calculate the standard deviation of the sample. So since you need to calculate the standard deviation of the sample, then we need to use the T calculated this time. Okay, so uh, for step 3, before you can calculate the T calculated, step 3 is the test statistics, right? Test statistics. You need to first find the S, standard deviation of the sample. And the formula is given by summation of x squared minus summation of x squared over n minus 1. So let's do this together. Um, how do we do this? I think we need to construct a table first. I will just construct the table here. So this is our x and x bar. Our x is 60, 56, 60, 55, 70, 55, 60 and 55. Sum up all this, you will get summation of x. What is the summation of x? Anyone? What is the summation of x? It is equal to 471. 471. And if you sum up all the x square values here, you should get summation of x squared that is equal to 27911. Okay, so these values, these values will be used to calculate the standard deviation. And this is equal to summation of x squared to 7911 minus 471 square, and we have how many? N sample of 8 over 7. This is n minus 1. So solving this equation, you should get the standard deviation of the sample that is equal to 5.080832. So this value will be used in the calculation of the T calculated. So now you can calculate T calculated x bar minus mu over standard deviation of the sample over square root of n. And x bar is equal to, again, what is our x bar? 58.875. 58.875 minus mu that we want to test, 55 over this value, 5.0832 over square root of n. So the T calculated is equal to 2.1562. 2.1562. So this is the T calculated, and step 4 is the critical value. So find the T critical value because you use the T calculated. Okay, we need to compare with the T critical value, and the T critical value is T alpha and minus 1. Again, why alpha only? Because we uh, are using or testing one tail test. Okay, we are testing the hypothesis at only one side of the distribution. So alpha is given by 0.1. Okay, 0.1, 0, and n minus 1 is equal to 7. So go to the statistical table, find the t critical value. It's not this one. Find the t critical value. So 0.1 alpha, and the degree of freedom is equal to 7. Therefore, the value is equal to 1.415. 1.415. Go back to this module, and the critical value is equal to 1.415. You need to compare these two values. And since we are testing the hypothesis at the right tail, so step 5 for the decision rule, reject H null if T calculated is greater than T critical value. Okay, for right tail test, remember again, for right tail test, what is right tail test? Again, this one, the alternative is we use greater than symbol. That is a right tail test. For the test statistics, you should get a positive value, and you need to compare with the positive t critical value. That is why, and for the decision rule, that is why the symbol here is also greater than. Why? Because we want to know whether the t calculated falls in the under the rejection region or not. So this is the t critical value of 1.415. We want to know whether it falls under this rejection region or not. So since t calculated is equal to 2.1562 and the t critical value is equal to 1.415, t calculated is greater than. So the t calculated is here. This is the t calculated, 2.1562, and it does falls under the rejection region. So step 6 is the decision. We can reject H now. And the last step is the conclusion. Step 7 is the conclusion. So just use this template. Okay, use this template. But now we reject H now. But by the way, this is for the previous example. So what you can write or conclude is there is sufficient or insufficient. Sufficient evidence. Okay, remember, if fail to reject, insufficient. If reject H null, so what we can conclude is sufficient lah, sufficient evidence to conclude that the next um the next statement should be obtained from the question or from the alternative hypothesis. In our case, what is the alternative? The mean. the mean salary of or the average salary of substitute teachers in school is greater than 55 ringgit. That the average salary of substitute teachers is more than RM 55 ringgit. Okay, that is example 6. Any question? Yes, no? No question?
Mm, no.
Okay. If there is no question, I will leave example 7 for you guys to solve by yourself. Please read the question carefully. Please read the output carefully. And by the way, if the if an output is given, what you have to do is usually you need to use the p-value to test the hypothesis instead of the test statistics. Use the p-value. But yeah, you can do it by yourself, but you may get different answer from the previous example. Because why? Because this time the significance level is 5%. It is not 10%. Okay, so for this one, you should do it by yourself. And if you want to check if your answer is correct or not, you can show me your work in our next class. All right. Last question. Any question before we end our class for today? No question? Okay.
No.
Okay, thank you. So if there is no question, I think that's all for today. Thank you very much. And see you again in our next class. Don't forget to sign your attendance in the future. Okay? All right, with that, I end this class with Assalamualaikum warahmatullahi wabarakatuh and see you again. Thank you.
Salam.
Waalaikumsalam. Thank you, Doktor.
Kesalahan tingkah
Welcome.
Thank you, Doktor.